بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 2.3 and it's about business applications using Quadratics. So we have seen in chapter 1 uh, how to find the break-even points when the cost function and the revenue function are linear functions, and hence the profit is a linear function. Now we will consider here cases when cost function, revenue function, profit function are quadratic functions. So uh, we know how to find the break-even point. We have two cases. If you remember, either the revenue is equal to the cost function, and we solve this equation for x to find the quantity x, or the profit. We put the profit equals to 0 because the profit is the revenue minus the cost. The revenue function usually we could in a monopoly market only one whereas only when a company's product is the only one available. The selling price uh, the company sets determines the number of units sold. So the company sets a selling price, and this determines the number of units sold according to the product's demand function. In this case, the relationship between the price P of the product and the number of units is described by the demand function P equals F of X. So what is new here that the price would be written as a function of X. So in chapter 1, the selling price was given. The selling price is 50, is 30, but here the selling price would be a function of X. For example, X plus 1, X plus 2, okay. And we find the revenue function, the total revenue function, as usual by multiplying the price times the number of units, but the price here is a function of x. The price is a function of x. So let us see an example. Suppose that in a monopoly market, the total cost per day of producing a high-tech product is given by. So as you can see, this is the cost function, and it is a quadratic function. Suppose further that the daily demand function. Now this is the demand function, means the price, okay? The demand for this product. So this is the selling price. And as you can see, the selling price is written as a function of x. Find the number of units that will give the break-even point for the product. So he's asking about the number of units, which is x, that will lead to the break-even, and we know the break-even when Rx equals Cx. So we have the revenue function, how to find, the cost function, how to find the revenue function. The revenue function is, as usual, the number of units times the price. But the price here is a function of x. So it's x times 500 minus 2x. So the revenue function is 500x minus 2x squared. And we have cost function quadratic and revenue function quadratic. So to find the break even, we set them equal to each other. So C of x equals R of x implies 360 plus 100x plus 2x squared. This is the cost function equals the revenue function, which is 500x minus 2x squared. So actually the only change here is that you will solve a quadratic equation instead of solving a linear equation. And to solve a quadratic equation, you have to take everything to the left-hand side. So I have 2x squared here, and here I have negative 2x squared. This negative 2x squared, when you take it to the other side, it would be also positive 2x squared. So 2x squared plus 2x squared, I will have 4x squared in the left hand side. And then I have 100x here and 500x here. When you take it to the other side, it would be minus 500. So 100 minus 500 is minus 400x. And then I have plus 3600 equals to 0. Now, if all these numbers, yeah, I think 400 divides by 4 and 3600 divides by 4. So I can make it easy by dividing all numbers, all terms by 4. So this will give you, I think, yeah, 900. 3600 divided by 4 is 900. And then you have this equation. Okay, you can solve this equation. Try to solve this equation either by factoring or by using the quadratic formula. These are the only the two possibilities we mentioned in this section. Or you can think of two numbers. Their product is 900 and their sum is negative 100 to try factoring. And if the numbers are big, you can just use immediately the quadratic formula. But here x times x, and if I multiply negative 90 times negative 10, then their product is positive 900 and their sum is negative 100. So either x is 90 or x is 10. So when we have a quadratic function, when the cost is written, the cost and the revenue are quadratic functions, we usually have two solutions for x. So the number of units will give the break-even point would be either 90 or 10. Okay, so 90 units when they produce and sell 90 units, they will break even. And also when they reduce 10 units, they will break even. So the point of intersection of the revenue function and the cost function is called the break even point. Intersection between revenue and cost is the break even point. This is the cost function. Well, the cost here is not degree 2, it's linear, and the revenue is degree 2. Finding the break-even point requires solution of what equation? Well, we solve this equation, Rx equals Cx or Cx equals Rx. Find the break-even points. So we have 370x, which is the revenue function, minus x squared equals the cost 120x plus 15,000. Let us take everything to the left hand side. So I have 370x on the left hand side and minus 120 when I take it to the other side. So I will have plus 250x and 15,000 when you take it to the other side, it would be negative. So I'll have negative 15,000 equals to 0. Well, the coefficient of x squared is negative, so I will multiply by a negative sign to make it positive because I like it to be positive. So x squared minus 250 plus I multiply the negative 1 by all the terms. So x squared minus plus. And now, as usual, you can use the quadratic formula or factoring. Using factoring, you will try to think of two numbers, their product is 15,000 and their sum is negative 250. If you can find out, or you can use the quadratic formula. Well, 100 times 150 will give you 15,000. And the sum of negative 100 and negative 150 is negative 250x. So either x is 100 or x is 150. So they will break even if x is 100 or 150. He, he asked here about break even points. So I will find the points. So the first point is 100, and I can replace x by 100 either in the cost function or in the revenue function. I'll choose the cost function because it is linear. It's easier for me to uh, substitute there. So this would be the first break even point, and the other would be I'll just replace x by 150, and the answer would be 33,000. So if they produce 100 units, the cost and the revenue would be equal to 27,000. When they produce 150, again, the cost and the revenue would be equal by 33,000. The second point in this section is how to maximize the profit or the revenue. Well, when we talk about a quadratic function, we know that if a is greater than, uh, if a is less than 0 in the quadratic function, if a is less than 0, then the parabola opens downwards. And if the parabola opens downwards, then hk, the vertex, is the maximum point of the parabola. K, so if the profit is written as a quadratic function with a less than 0, so the maximum profit would be k. Okay, the maximum profit would be k. And the number of units that maximize the profit would be h. Also, the revenue function. If the revenue function is written as a quadratic function where uh, a is less than 0, same. So k would be the maximum revenue, and h number of units that maximize the revenue. So for example, here in this question, the revenue function is written as a quadratic function with a less than 0. So if you want to find the maximum revenue here, it's just k. Okay, and you remember how to find h and k. We said that h is negative b over 2a, and k is f of a. K is f of a. Sorry, f of h. F of h. So here for the daily total cost, so this is the cost function. It's given as a quadratic equation, quadratic function, and the daily total revenue, and the revenue is also a quadratic equation function. Find the number of units that maximize profit and find the maximum profit. Okay, the profits, what is the profit? The definition of the profit function. The profit function is the revenue function minus the cost function. So it is 500x minus 2x square minus the cost function, which is 300, 3600 plus 100x plus 2x squared. And this equals to 500x minus 2x squared, and then we distribute the negative sign to all terms. And now we have negative 2x squared, negative 2x squared. This will give you negative 4x squared, 500x minus 100x. This is 400x, and I have negative 3600. Okay, this is the profit function. And you notice that A is negative. Notice that now this is a function, okay? This is the profit function. So you cannot multiply now by negative sign to make A positive because you will change the function. And you cannot divide by 4 because that's the profit function, okay? Uh, if you put it equal to 0 and make it an equation, then that's something else. So this is the profit function. You have to deal with this definition. And what do we need to do? We need to maximize the profits. So the maximum, the question, find the number of units that maximize the profits. This is in fact H. Okay. So what is H? A here is negative 4. B is 400. So H is negative B, negative 400 over 2 times A. Okay. So if you divide negative 400 over negative 8, the answer is 50. So 50 is the number of units that maximize that maximizes the profits. Okay, so 50 units will give you the maximum profits. Well, what is the maximum profit? So the maximum profit is K, and K is P of 50. You just replace X by 50. So it's negative 4 times 50 square plus 400 times 50 minus 3,600. All right. And then you get the answer. If you plug in the numbers correctly in the calculator, the answer is 6,400. So this is what? This is the maximum profit. The maximum profit is $6,400. So this is the idea of asking maximum profit or maximum revenue, because if they are written as quadratic functions, then the vertex will give you the maximum point. Same idea when we deal with supply, demand, and market equilibrium. If the demand equation, this is an example, if the demand equation is given by this, P is the price, Q is the quantity, and the supply function is given by this, Q in thousands. Find the market equilibrium. Well, here, notice that P times Q will be an equation of degree 2. Okay, it will make it quadratic because P times Q, two variables, when you multiply by each other, it is similar to a quadratic function or equation. Now, how to find the market equilibrium? If you remember the market equilibrium, when the demand equals to supply. So I need to put these two equations equal to each other. Well, this equation is P times Q plus 4 equals 400, and this one like this. So what I can do, for example, I can solve this equation, the second equation, I can solve it for Q. So let me write 2P minus 38, and let me take Q to the other side. So from this equation, from the second equation, the supply function, I solve the supply function for Q. And then I can plug this in the demand function. Okay. So I can write it P times Q is 2P minus 38 plus 4. So Q is 2P minus 38, and there is plus 4 here equals 400. And this really solving the two equations together by substitution. Okay, this is the method of substitution. You solve one equation for one variable, and then you substitute with it in the second equation. Now, when you solve this, when you expand, I will get 2p squared minus 38p plus 4, uh, all right, plus 4p. I could just subtracted negative 38 plus 4, but I'll do it now. Negative 400 would be equal to 0 when you take 400 to the other side. So I will have 2p squared, and now negative 38 plus 4 is just negative 34p minus 400 equals to 0. Now I have an equation. You see, I have an equation. So I can divide this equation by 2. So the equation would be p squared minus 17p minus 200 equals to 0. And this is a quadratic equation. And you can solve this equation either by factoring or by completing the square. Uh, if you think of two numbers where their product is negative 200 and their sum is negative 17, you will find negative 8 and positive 25, or in fact, positive 8 and negative 25. Now, if you multiply 8 times negative 25, you will get negative 200, and if you add them, you get negative 17. I hope, uh, yeah, all what we did before is correct. Yes, it is. So either P now, either the price is negative 8 or the price is 25. But you know, the price cannot be negative in real life. So this answer is rejected. And we have one answer here that the price is 25. The question, find the market equilibrium. So this is the equilibrium price. To find the quantity, I can just, yeah, use this equation. So I can find Q by multiplying the price, which is 25 by 2, subtracting 38. So this will give me 17, or, yeah, 12. Sorry, it will give me 12. So 12,000, okay, because Q in thousand. So the market equilibrium would be, the market equilibrium point would be 12 and 25. So this is Q and this is P. Remember, we put P in the y-axis. So this would be the market equilibrium. So the point of intersection of the supply and demand is called market equilibrium point. Okay, equilibrium point. If the demand and supply functions for a product are as follows, respectively, find the market equilibrium point requires solution of what equation? Of these two equations together. Okay, we need to solve these two equations together. Find the market equilibrium. Well, I can solve the first equation for P by taking 1 over 10 q squared to the other side. And then I have P here and P here. So I need to solve the two equations together. So I write negative 1 over 10 q squared plus 1000 equals 1 over 10 q plus 10. So this is another way, okay? Or you can plug P 1 over 10 q plus 10 here, substitute with P here, and you will get the same equation at the end. So I have negative, let me multiply by 10 to get rid of the denominators. So I have negative q square plus 10,000 uh, equals q plus 100. So I multiplied by 10, okay, to get rid of these two denominators. And now I'll have negative q square minus q, okay, plus 10,000 minus 100. So 10,000 minus 100 would be 19,000, 90,000. This is an equation, so I can multiply by a negative sign to make the coefficient of q squared positive. So the equation is q squared plus q minus 9900 equals to 0. And again, this is a quadratic equation, and you can solve it either by factoring or by completing the square. And if you think of two numbers, their product is negative 9900, you will find uh, a negative 99 and positive 100. So I hope you differentiate here between q and 9. Q minus 99 minus 99 times 100 will be minus 9900, and their sum will give you 1. So either q is 99 or q is negative 100. But q is the amount, the number of units supplied or demanded, and it cannot be negative in real life problems. So this solution is rejected, and q is 99. To find the market equilibrium, I need to replace q here or here. I will use this one now because this is a first degree. So I will find P from that equation 1 over 10 times 99 plus 10. Okay, 1 over 10 times 99 plus 10. And the answer would be 9.9 plus 10. So it is actually 19.9. So the market equilibrium would be market equilibrium. Uh, Q is 99. This is Q. And P is 19.9. This is the price. All all the numbers are 9. A lot of nines with Qs. I hope you understand the number and the letter. Well, this is the end of the section. Thank you very much and enjoy studying.